My job here is to talk through the economics of sort of climate change research and link that into what we do at Ohio State. We do a lot of it at Ohio State, and it's exciting to talk about. So when I think of climate change economics, I sort of break it into three areas of research. I want to talk through those three areas with you today. The first one is, economists like to take these impacts, these physical impacts, and translate them into dollar values. I mean, we're obsessive with this idea that we can translate just about everything into a dollar impact, a dollar number. And we do that because we know for a fact that anytime someone says, you need to do this to reduce climate change, they're going to come up and say, well, it's going to cost me this much, so what's the benefit, right? So our obsession is to try to calculate what some of those benefits are. We also look at the cost side as well, as I'll talk about. We do that in the market areas, traditional market areas, sectors you might think about: agriculture, forestry, water, household energy, health, et cetera, et cetera. So these things are kind of easy to do because we have a lot of data associated with them. Non-market areas are also vitally important and becoming more and more important, obviously, because our incomes keep going up and we spend a lot more time doing leisure activities. And so this stuff is really valuable. I don't know if you saw the study a year or so that came out from the Bureau of Labor Statistics or Department of Commerce, the people who collect our GDP data. They basically said that outdoor recreation is now about 3% of our economy. That's bigger than agriculture, right? It's a huge sector in our economy and growing every day just because our incomes are going up and that's where we spend our time. Adaptation, I thought I was going to have trouble with that. Thank you so much for, this is the third rail of sort of climate change research, right? It's the thing you're not supposed to talk a lot about, but it's the thing we all know because we already have, whatever, 1 degree or so change in temperature already. We're already adapting now. And, we'd love to go negative. We all would, but there's a chance that's probably as big as any that we're not going to go negative on these emissions. So we're going to have to adapt. So adaptation research is really important, and we have a lot of that going on at Ohio State. And then the policy research. So looking at this sort of optimal policies, we'll talk about the social cost of carbon and then assessing benefits and costs. So let me sort of talk through each of those areas and what we do at Ohio State. So in the economic impacts of climate change, there's sort of two sorts of approaches that are used. The first approach is sort of the natural experiment approach. This is best thought about maybe in the agricultural sector. Modern agriculture is, say, I don't know, anywhere between 10,000 and 200 years old, depending on what you consider the first or the second agricultural revolution as modern agriculture, right? But agriculture is climate adapted, right? So we do agriculture in specific places because of what the climate gives us. So as economists, we then take that and we can translate that very, very nicely, actually, into economic outputs, right? And we know, for example, that the optimal sort of average temperature for agriculture globally is about 11.5 degrees or something like that, centigrade. It's average annual temperature. And that's about the temperature of Ohio. So we're in this perfect place in Ohio, right? And then we can take that information then to measure what happens as you move to ever warmer temperatures and translate that into an economic impact. But we can also do that in other areas of population migration, which I'll talk about in just a second. Then there's a whole bunch of work where we don't have good observational data, and we have to actually take a much more modeling-based approach to link in these sort of climate models with some sort of a physical or science-based model, ecosystem model in the case I'll talk about, and then link that into the human model. So it's a modeling-based exercise in places where we have less data where we can show sort of the climate impact. So let me give you two examples of these things. The first one is a great study by my colleague, Alan Kleiber, in our department. We don't have great pictures in economics, so I just have to have a table. So I apologize. But, it's a meaningful table maybe. So we are consumed by that last column, the welfare effect. That's a dollar value effect on people. So what Alan did, and this is interesting, so he basically, we have observed that people live in places for certain reasons. And one of the reasons why they live in one place or another happens to do with climate, the climate that exists in that place. So they did a sort of a national scale, what we call sorting models. That's just how people sort themselves, right, on climate and other variables like wages and other kinds of things that are important for where people live, right? So he did sort of a national-based model of that and said, well, a component of that is related to climate. So let's just look at the 2065 climate. I forget what the climate model they used was, and then say how people resort themselves, right? Then they face this other problem, which is that it's not just climate that matters, it's also wages. The biggest reason why people migrate is because of wages. So then link this into what we call a computable general equilibrium model to calculate all these other effects and calculate the resulting wage effects of shifting people around the country. And they found that, maybe it is a surprise, I don't know, that the the negative consequences of climate change on migration and therefore on people's welfare, economic outcomes were worse in the Midwest and the South. Probably not surprising in the South because that's been warm to maybe somewhat inhospitable areas. And even though people love air conditioning, they still want to get outside once in a while. Some gains in the Northeast, and the West and California continue to gain. So that's an interesting study using sort of a mix of actual data and modeling data. Here's some sort of couple human systems research that I'm engaged in, where we're linking together general circulation models with vegetation models that sort of project at the half-degree grid cell level what happens globally to vegetation systems, that is changes in biomes, different kinds of ecosystems, et cetera. And then we link that into economic models and make a projection of what happens to human management. So one of the things, forest fires are an important thing in forestry, right? And they're an important thing for people to manage their way through. And so with climate change, with these ecosystem models, you get projections of changes in the amount of fire that will occur in these different sort of half-degree grids around the world. And then our task is to link that into an economic model, which makes broad assumptions about human behavior, but still makes an assumption about human behavior and then tries to model how people will adapt to that and model the consequences. In this case, what we did is just model the consequences for two things, that is timber harvest and carbon storage, because we're interested in the feedback between climate change and carbon storage in these ecosystems, especially as they're perturbed by fires. So those kind of two examples of economic sort of impact analysis. We don't do this kind of research. I just wanted to give you a sense of what economists now, the average or the aggregate estimate of damages from climate change, just so you know what the number is. This is from Richard Toll. He's, he makes a lot of people mad, but he's done some great research here, which helps us actually aggregate these numbers. So I keep pointing at this thing. Isn't that stupid? Because you can't see me pointing at this. Okay. Anyways, the point of this is that at a 3-degree temperature change relative to prehistoric time, the average estimate of the aggregate impacts on society in economic terms are about anywhere between a half to up to 5% of GDP. So that's an enormous impact. You think of our GDP at about $80 trillion per year. By the time we get to 3 degrees, it's going to be far bigger than that. That's a big impact, right? So that's just to give you a sense of what the scale of impacts are. Okay, the different area where there's a lot of research at Ohio State is adaptation analysis. Joyce Chen, one of my colleagues in AED economics, just had this recent paper come out in Nature Climate Change, where they were looking at Bangladesh, and this is a place that's likely to be heavily affected by inundation, sea level rise, et cetera, relatively not wealthy population who are farming, right? And the question is how are those impacts going to affect farmers in these coastal ecosystems who are making their living farming, and they don't maybe have the same set of alternatives that farmers in the U.S. do in other places, right? So the interesting thing that Joyce and her colleague found in this study were that farmers, they could adapt. They could adapt to do some aquaculture. So there were some things they could adapt, but one of the things that would happen was that they would have to migrate. That there would be a lot more migration. So climate-induced migration, sort of as a result of not so much the sea level rise. What they found was there was a really indirect effect. So it's kind of interesting that salinity would increase saltiness of the soils, making agriculture a lot less productive. So even though they weren't affected by sea level itself, the rise in sea level, they would be affected by indirectly through the salinity effects. So interesting study there in that part of the world. A different set of adaptation analysis also in the tropics. Interestingly, we do a lot of work in the tropics looking at agriculture because that's where the biggest impact. It's interesting, the biggest physical impacts of climate change seem to be sort of in the Arctic zones, right, the north and the south. But the biggest economic impacts are undoubtedly in the tropical zones because that's where people who are a lot less well off than we are, who have a lot fewer adaptive opportunities than we do, exist. So Abdul Sam, I forgot to put Mario Miranda, also in my department. He was a part of this research as well. Mario's an expert and Abdul are experts in insurance contracts. And so they thought, can we design insurance contracts for folks in Ghana, help them use insurance as a mechanism to help adapt to climate change. And so they did that, a nice study. They use these things called randomized controlled trials. Basically, it's what if you have a lab, do with a petri dish. They do that with people in these places. And actually figure out how, what kinds of levers in these insurance contracts would help farmers adapt them and use them effectively to adapt to climate change. The final research for adaptation analysis I want to talk about is this work by Satya Gopalakrishnan on coasts in the U.S. A huge amount of our income occurs on the coast, right? Makes all of us in the Midwest sort of, look bad in comparison. But a lot of the income is on the coast, and a lot of people live on the coast, right? So there's a big impact there. And Satya's work to link in sort of hydrologic models with human behavior models has been path-breaking in this area to help us understand what some of the economic implications of climate change would be for a huge swath of basically the American economy, right? So the last thing I want to talk about is sort of the general policy analysis, the sort of bigger picture of climate change. And this is just, I wanted to just talk for a second about the social cost of carbon. That is a technical term in economics. It's basically what we call the present value of damages caused by 1 ton of carbon emitted today. So we're trying to account for the fact that if you put a ton up there today, it's going to stay there for a long time. It's going to add together with the historic tons and the future tons to create increasing damages over time, right? And we just do a present value calculation of what we think those damages are going to be from that 1 ton that was emitted today. And the nice thing about that from an economist perspective, and this is how it was used in the Obama administration when they're putting together the Clean Power Plan, was they basically said, the current estimate of the social cost of carbon is, they were using, I think, $34, a 3% discount rate. They said any action, any cost that's less than $34 can fit into our Clean Power Plan, right? So that's basically how they would use this social cost of carbon concept. So let's keep that in mind. It's actually very relevant and useful from the policy perspective. So what are the contributions to this at Ohio State? And we have a surprisingly large number of them. So one of the things we've done is taken the biosphere and added it into these models that calculate these social costs of carbon. So most of the models that calculated the social cost of carbon didn't have an active forest that could actually sequester carbon from the atmosphere. And it turns out that that's actually an important component of some of those measurements. So we added that in and got an effect. In fact, interestingly, you might find that human management of the, we've experienced a lot of increase in carbon dioxide for the last century in the atmosphere, which has fertilized our forests. So people look at these huge increases in the biosphere carbon base and say, oh, that's just due to carbon fertilization. Actually, about 30% of that is due to actually human management. And so that's an important component that's affected the social cost of carbon. Jeff Balecki's work, he talked a bit about that, but the carbon capture and storage has also been added into these models. And then perhaps the most important thing is this work by Yongyang Kai in our department, who's added in the stochastic element and shown that 31 is not the right number, 34 is not the right number. Really, it's more like 3 or 5 times that. If you add in the fact or the idea that there's stochasticity out there, right? So important contributions to this integrated assessment analysis area that we've tried to make. So the last area of sort of policy research that happens here at Ohio State is work on carbon trading. So Noah Dormady in the Glenn College has done work on carbon trading as an expert on carbon trading and how that intersects with the energy market. I mean, some of the concepts that Jeff brought up earlier about pricing of electricity, interday and whatever, these fluctuations in when we demand electricity, when we need get the supply of electricity, how that relates to carbon markets. Noah's an expert on that, has done a lot of research in that area. That's a really important thing to understand if we're going to try to fix the problem. And then, my own work as well with Daniela Miteva in our department. Let's look at this area of sort of nature-based climate solutions. They just had a big paper come out on nature-based climate solutions in Science Advances, showing again that nature can actually be about 30% of the solution to climate change. And it comes down to how do we find the cost-effective components, how do we get people to change their behavior to actually do some of these things, et cetera, et cetera. So that's kind of it in terms of the economics. I probably left someone out, and I apologize if I've done that. That's kind of a broad overview of what we do here at Ohio State. Thanks.